All right, tonight we're going to talk about composite geometric shapes. That's just more than one geometric shape combined. You may add them together or you may subtract them together. It depends on if the shape combines to make a bigger shape or if you're taking away a shape. So on this one, the first thing we want to look at is I notice that there is a cylinder. Here's your cylinder here. And then here is your cone. So we want to combine the cylinder and the cone. So if I want to find the volume of the cylinder, remember the volume of a cylinder is V equals capital B times H, and the base is a circle. So to find capital B, I need to use the area formula for a circle, which is pi times r squared. And if I look at the circle, the radius of the circle is going to be half the diameter, which would be 2 squared. And the height of my cylinder would be 2 inches. So if I want to find the volume of the cylinder, I just put in pi times 2 squared times 2. And that tells me that my cylinder is going to be 8 pi. Then I need to find the volume of my cone. Alright, so I notice I have the cone here. Remember the volume formula for a cone, since it only has one base, you start with 1/3 capital B times H. Again, a cone has a circular base, so I've got to use the area formula for a circle for capital B. So that's going to be pi times r squared, and r is still half of 4, so that would be 2 squared. And then my height of my cone is going to go from here to here. So if from this distance to this distance is 2, and the total distance is 5, the height of my cone would have to be 3. So to find the volume there, I would hit the fraction button, and I would say 1/3 times pi times 2 squared times 3, and that would give me 4 pi. So to get the total area of the cylinder and the cone, I'm going to add them together because the cone's on top of the cylinder. So that get me a total volume of 12 pi. So my composite geometric shape has 12 pi. For time's sake, I'm not going to work this one. You might want to see if you can work this one from extra credit. This is a prism, and that is a pyramid. So if you want to try to work that one, go ahead. I'm going to move on. On this one, in my picture, I have 2 cones. Alright, I have a large cone and I have a small cone. What I'm actually doing in this composite function is I am taking the large cone, and out of the large cone I'm going to take away the smaller cone. So instead of adding this time, I'm going to subtract. So I need to find the volume of the large cone. Remember, the volume formula for a cone is 1/3 because it only has one base. Capital B times H. Alright? And again, my base is a circle. So capital B is going to have to be the area of a circle, which the formula sheet tells you is pi r squared. And r for the large cone is going to be 8. And the height of the large cone is 12. So I need to get my calculator out, and I'm going to say pi 1/3 times pi times 8 squared times 12. And the area for my large cone is 100 pi. Then I need to find the volume for my smaller cone. Again, I'm going to use the volume formula for a cone, and since it only has one base, I'm going to use the 1/3 capital B times H. So I start with my 1/3. The smaller cone has a base that's also a circle. So I'm going to use pi r squared for the area of a circle. And the radius of my smaller circle is 4, so 4 squared. And the height of my smaller cone is 6. So I need to put that in my calculator. So 1/3 times pi times 4 squared times 6 gives me 32 pi. And since I'm going to take the smaller cone out of the larger cone, I want to subtract instead of add. So 100 pi minus 32 pi is going to give me a total of 68 pi. And that's going to be my volume. I could also include my dimensions here. That would be inches, and volume is always to the 3rd power cubed. Again, I'm going to skip this one. Alright, you might want to try this one. Notice I'm starting with a prism, and I'm going to take a pyramid out. So extra credit for anybody who wants to try to do that one. Alright, now, this is a little bit different. Alright, I'm still wanting to find the volume of a cone. So my formula is still going to be 1/3, because it only has one base, capital B times H. Alright, so I know I'm going to say 1/3, and since this is a circular base, I'm going to use my circle formula, times pi times 16 squared. Need to make sure my exponent's inside the parentheses. The problem is 34 is not the height. I need to know the height for my formula. Alright, 34 is actually the slant height, because it measures this slanted value here. And notice I have a right triangle, so I could use the Pythagorean theorem. A squared plus B squared equals C squared. To find my height, I know the hypotenuse is 34 because the right angle is pointing to it. So that could give me 16 squared plus B squared equals 34 squared. So I want to work that out. 16 squared is going to give me 256 plus B squared equals 34 squared. And that's going to give me 1,156. So to solve for B squared, I need to subtract 256 from both sides. They cancel on the left. That leaves me B squared. So I just need to subtract 1,156 minus 256, and that gives me B squared equals 900. So if I take the square root of both sides to find B, that's going to give me B equals 30. So I know that my height is 30, so I would put it over here in my volume formula. Then all I would need to do to find the volume is put it in the formula. 1/3 times pi times 16 squared times 30. And that tells me that my volume for this pyramid is 2,560 pi. Remember that you have to know the height, and the height has to be perpendicular to the base. So if you're given the slanted version, you've got to use the Pythagorean theorem to find the height. Here's another example. I'm not going to do that one for time's sake. Again, extra credit will be given to anybody that does that one. I'm also going to skip this one because there's an issue with this one and it can't be worked. And we'll work the last one here. This is a pyramid. Remember, the volume formula for a pyramid is 1/3 capital base times height. Alright, so that's going to give me 1/3. Now the base of this pyramid is a rectangle. So to find the area of the rectangle, I need to multiply length times width, which is 10 times 8. And then I need to also multiply the height. Now notice here, again, I do not have the height because the 14 is the slanted part of this pyramid. So what I want to do is I want to form my right triangle here. I know that the hypotenuse is 14. And the distance from this point here to the right angle here is going to be half of 8 because it's halfway through the pyramid. So that would be 4. So I would use the Pythagorean theorem, which says a squared plus b squared equals c squared. I know my hypotenuse is 14, so that would be 14 squared under c. A would be 4 squared plus b squared. If I work that out, that gives me 16 plus b squared. 14 squared is 196. If I subtract 16 from both sides, that's going to give me b squared, cancels on the left, b squared equals 180. So to find the value of b, I need to take the square root of both sides. So the square root of 180, 13.4. And I rounded that to the nearest tenth. So to finish my volume, I need to put 13.4 for my height. And then I put the numbers in. So I say 1/3 times 10 times 8 times 13.4. And that gives me a total volume of 357.3 repeating. And again, if I wanted to use my dimensions, I would say inches to the third power because volume is always cubed. So that's how you do slant, height, and composite functions.